Hey everyone, welcome to this video. So this is actually a two-part series. We're in the second part of balancing equations. In our last video we talked about finding out whether an equation is balanced or not balanced. This video is all about making it balanced. So maybe we realize, hey, it's not balanced. What can we do to make it balanced? So we might be changing the reactant side, we might be changing the product side, or we might even be changing both. This is super important if we need a set amount of product and we need to know how much of each element or each compound we need on the reactant side. Or vice versa, we want to know how much of a product we're going to get. So let's take a look as we jump through a couple different problems. My setup might not be the same as yours, but this is the way I found it easiest to teach, easiest to apply it to these problems, so follow along with us. Okay, our first problem is blank Mg plus N2 yields Mg3N2. First thing I do, I draw a line below the arrow. This divides up the reactants and products. I list out the elements that I see on the left-hand side and the elements I have on the right side. Make sure you're not just kind of assuming that those elements are there on the left and on the right. Now, we place a 1 in the blank. That is kind of like our little place filler. We don't know exactly what number is going to go in there, but if we don't make any changes, maybe this is balanced already, we would leave it as a 1 or we'd leave it blank to assume that it's a 1 coefficient. All right, if we fill in how many atoms of magnesium there are 1, 2 nitrogen. On the right-hand side, we have 3 magnesium and 2 nitrogen. Now, we've already noticed that it's not balanced. What isn't balanced, and I like kind of go back and make a little X here, the magnesiums aren't balanced. So what number can I put in this blank? So if I take away this 1 and say I put a 3 there, that's going to show me that now I have 3 Mg, so I can go back and change this. And that's the only thing that's impacted by changing that coefficient, right? Because there's a plus sign, so the nitrogen isn't affected. Now if I go back through, okay, I no longer have that error where the magnesiums didn't match up. Nitrogens still match up, magnesiums match up. Make sure you go back and check every element to make sure they're matched up. So the end result, okay, I can erase kind of my beginning mistakes for my first steps. I have 3 Mg plus N2 yields Mg3N2. So now it is balanced. Let's take a look at a little bit more of a complicated of a problem. Okay, here I have 2 KNO3 yields a blank KNO2 plus O2. Now this gets a little tricky, and the reason for it is oxygen on the right hand side, on the product side, is actually listed twice. So go ahead and write the elements down. Right, potassium, nitrogen, oxygen. We have those 3 on the right hand side. Okay, so I have 2 potassium, I have 2 nitrogen from that coefficient, and now I have 2 O3, so I have 6 oxygen. On the right hand side, right? Again, I'm assuming there's a 1 there. There's 1 potassium, I have 1 nitrogen, I have 2 oxygen here on this problem, and this second part of the product, I have 2 as well, so now I have 4. So, let's start with the first one I have listed. Potassium is not matched, right? 2 versus 1, nitrogen 2, 1, right? So nothing is matching them, nothing's balanced. So the first thing I want to impact is the potassium. Let's go ahead and change this to a 2, and just so you can see a little color difference here, I'll change it to blue. So if I change this to a 2, now that 2 is going to impact the potassium to 2. It's going to impact the nitrogen to 2, and it's going to impact the oxygen, right? 2 O2s, so now I have 4 oxygen, plus, don't forget about these 2. I have 6 total. So now we're balanced here, where previously we were not. So now we have the proper balanced equation, right? So 2 KNO3 yields 2 KNO2 plus O2. All right, so there you have it. Okay, a balanced equation. So now we're looking pretty. The next problem, uh-oh, now we got 2 blanks. All right, so now we're stepping up the ante. But again, if we're taking the steps slowly, we should be able to solve this with the same method. Okay, draw our line. We've got iron, hydrogen, sulfur, and oxygen, and we have the exact same thing. I like to make sure that even though the hydrogen's not next on the product side, I like to put it right across from where I had the previous one, S and O. Now hopefully if you are doing this on a worksheet or on a test, right, you have the room, the space to do it. If not, I'd definitely get some scrap paper, some work paper to make sure we're able to do that. So again, we're going to put ones in as placeholders for the coefficient. We have 2 irons, we have 2 hydrogens, we have 1 sulfur, and 4 oxygens. On the right product side, we have 2 irons, we have 2 hydrogens, we have 3 sulfurs, and now we have 12 oxygens, right? Because that coefficient, or I'm sorry, that subscript 3 is for that SO4. All right, so 3 S's and then we have 4 O's, or oxygens. All right, so if we take a look, right, the ions are now balanced, right? So that's good. Woohoo! All right, the hydrogens are balanced. The sulfurs are not, and the oxygen are not. Oh no. All right, so let's take a look. Since we have more on the product side, we're going to really manipulate the left side of the equation. Okay, starting with sulfur, what number can I put in there to actually change this to get to 3 sulfur? So if I have 1, if I put a 3 in there, if I change this to 3, and again I'll change the color here so we can see that difference. Okay, if I change this to a 3, that 3 is going to impact 3 different elements. Now if I go through it, it's going to impact the hydrogens to 6. Oh no, what was balanced is no longer balanced. It's okay. Right, we're applying it. So go ahead and go through the whole thing. Now we have 3 sulfurs. And now we have 3 O4s, 12 oxygens. So despite balancing out the sulfurs and oxygens, now we have an issue with the hydrogens. Okay. We have more hydrogens on the reactant side, so let's go ahead and manipulate the right-hand side. And look at that. We actually have a place where we can manipulate just the hydrogen. There's 6 on the reactant side. We need to have 6 on the product. Now it's H2. So if we actually change this to 3, what that does is it changes it to 6 hydrogens total. So if we run through now, okay, if we kind of want to look at our final product, okay, we have something that looks like this. I'll take away the unnecessary. We have, and I'll put 3's back in there so we can have that nice and easy. We have 2Fe plus 3 H2 SO4s yields Fe2 SO4 with a 3, and then we have 3 H2, and there we go. It is a balanced equation. Now I would be lying to say that there isn't more to it. There is. We can definitely have 4 blanks. Here's another one that's a little bit simpler with only 2 blanks. It can get complicated where we have to go back and forth, and that's okay. There's nothing wrong with that. As long as we're showing our work, as long as we're making sure that coefficient is impacting both sides. This, well, I would hope you know which side we're going to be playing with the numbers. Only on the product side, right? Because there's no space in front of that MgCO3. But again, here we go. We have a situation where the oxygen is going to be added by both compounds, right? So here we go on the reactant side. We have 1 magnesium, we have 1 carbon, 3 oxygen. On the right hand side, we're going to assume there's 1s. It's 1 Mg. There's 3 oxygen, and there's 1 carbon. So there you go, that's balanced. We didn't even have to do anything other than make sure there's 1s there. So that was nice and easy. Okay, let's go ahead to the next problem. Okay, H2 plus N2 yields N. Okay, we've only got 2 elements. That makes it nice. Again, be careful and make sure that our hydrogens are across from each other. I know the ordering pair is different here on the product side, but again, if we start doing that, we're going to be trying to get numbers matching that aren't aligned, and it's a mess. Okay, I'm going to assume there's 1s in there, so we have 2 hydrogen, 2 nitrogen. On the right-hand side, we end up with 1 nitrogen, and we end up with 3 hydrogen. Okay, not right. So let's start with the hydrogens. We know the number can't be 1 because the hydrogens are less. So if we change this to 2, let's see how that impacts our problem. We got 4. Well, that didn't do us any good, right? What if we were to, let's see if we were to change that to a 3. Okay, we get 3 H2, so now we have 6 hydrogens, and we're still stuck. All right, we have a lot more hydrogens on the left-hand side. Let's go back to the right-hand side, see what we can manipulate, right? We know that nitrogen here has to at least be a 2, so let's go ahead and put a 2 in there, see if that changes it. So we have 2N, so 2 nitrogens, and now we have 2 H3s. Look at that, right? So again, we put in a 2 and that didn't work, and that's okay. We kept it. We just made sure we went back and added a different number, and we played this little game. It kind of looked at the least common multiple, which ended up to be a total of 6 for hydrogen. Okay, our next problem here is a doozy. We have 4 blanks, we have 4 coefficients. We need to figure out if one works. If not, we need to manipulate those 4. We draw our line down. Okay, let's not get too scared here. Okay. The same rules apply, it's like a bigger adding problem, okay? That's just about all it is. Just because there's a couple more numbers, there's a couple things that can change, that doesn't mean we need to panic. Let's go through the exact same way. Right, we've got 1 potassium. We've got 1 oxygen here in this compound, and we have 4 here, so a total of 5. Okay, hydrogens, we have 1 in this compound, and we have 3 there, so 4. And then, here we go, we only have 1 phosphorus. Okay, take a look at the product side. Okay, 3 potassium, we've got 4 oxygen plus 1 oxygen. It's 5. Hydrogens, we have 2. And then phosphorus, we only have 1. Okay, right off the bat, we notice that this is not compatible across, not balanced. The oxygens are balanced. Okay, we're going to hopefully not, look at that. So regardless of what number we change, we're going to be changing an oxygen. Okay, despite those being okay, we know that's going to not be the case. So we look at hydrogen, we know that's not balanced, and phosphorus happens to be. Okay, we can choose either one of these to start with. We could start with potassium, or we start with hydrogen balancing it out. Now, the way I like to look at this, I look to see which one's the easiest to change first, which one has the least amount of impact. If I look to change the hydrogen on the right-hand side, look what happens if I change this to a 2. What that does, it only impacts 2 elements. If I go to potassium over here and I were to change it, that actually impacts 3 elements, and I want to hold off. If I can find one that's a little bit more direct route, let's go that route. So if I were to change that to 2, and let me change my color here just so we can see that difference. Okay, so I changed this to 2. That impacted the hydrogen. That changes this to a 4. It also impacts the oxygen. Not only do I have 2 now here, I need to add it to those 4, and I get a total of 6. Okay, the hydrogens are now balanced. The oxygen are not. And again, the potassium is not. So let's go to the left-hand side. Okay, what number can I put in here to balance out potassium? The only number I can put in there is a 3, and that does what? 3 potassium. Now I have 3 oxygen plus these 4, I get 7. And then I have 3 more hydrogen, so 3 plus 3, and I get 6. Oh boy, just when you thought we were going to get better, well, now at least our potassiums are lined up. And our oxygen are not, so that's still an issue. And now what used to be balanced is not, or so our hydrogens are not. Oh boy, you're like, oh, this is going to be absolutely terrifying. Okay, if we're looking carefully, we have a lot more atoms on the left-hand side on the reactant side, so we need to come over here to oxygen and hydrogen, which we need to increase. Okay, so we see that hydrogen's going to be impacted over here, and oxygen is going to be impacted. So if we were to change just this number, let's go ahead and see what happens. Alright, so let me get rid of some of these X's and check marks. I'll change colors again. So this way, again, we're seeing the steps that are taking place. If we change this to a 3, now we have 6 hydrogen, and now we're impacting the oxygen as well. We have 3 here, plus these 4, and we get 7 oxygen. So yes, we took a little bit longer of a route, but we still ended with the correct answer. And we didn't have to stress, okay? That was nice. All our work was shown. 3 KOH plus 1 H3PO4 yields 1 K3PO4 plus 3 H2O. All right, so hopefully that really kind of gave you an idea of at least the steps that we would take to balance an equation. Okay, show your work, build those little columns beneath the product side and the reactant side. Okay, take a turn back and forth to see which one. Okay, there's no harm, there's no foul of starting over, but at least you don't feel like you're going around and around in a circle. Okay, maybe we change potassium first, maybe we change hydrogen first. Okay, it doesn't matter which one you change first, you'll still get there. As long as you're showing your work, you'll be able to kind of go backwards and forwards and gently increase each side to see what's going to work. All right, thanks for watching today's video. If you have questions, comments, definitely let me know. Either way, have a great rest of the day.